Hey everyone, welcome back. Today we are going to do something really interesting. Today we are going to create our smart contracts in the Rust programming language. Yes, you heard it right. We are going to create smart contracts in the Rust programming language. And how we are going to do that? We are going to do that using Soroban platform. What is Soroban? Soroban is the smart contract platform on the Stellar network where we can write our smart contracts in the Rust programming language, which then later get compiled into WebAssembly for the deployment. And in this video, we are going to see how to use the Soroban platform, how to use the Soroban Rust SDK in order to create our smart contract in the Rust programming language. So I have divided this video into two parts. In the first part, we are going to see how to use the Soroban platform, how to create simple smart contract on the Soroban platform, how to compile it, how to deploy it, how to test it. Then we are going to write a complex smart contract that would be an atomic swap smart contract where we are going to see how to swap tokens, how to do atomic swap between the tokens on the Soroban platform. And that will be a very interesting tutorial. I am going to teach you each and everything from scratch in a very step-by-step manner so that you can learn each and everything, and then you can create your own smart contract on the Soroban platform in a very simple manner. And yes, let me tell you about the two events that are going to be held in London, and I am going to these two events, and these are some interesting events that are going to be held in London. The first event is EasyA Stellar Hackathon that is going to be held from 12th of October till 13th of October. I will share the links in the description, as well as you can see the location on your screen where these events are going to be held in London. And the second event is Stellar Meridian Conference that is going to be held from 15th of October till 17th of October. Again, I will share the links in the description and I will share the location as you can see on your screen. If you want to join these two events, you can join. And I am going to these two events and I hope you are also joining these two events. Let's meet there and let's have fun together. Now let's start with the tutorial. So let's start with the process of Soroban installation, and for that we will be using this documentation, and I will be sharing the link in the description of this video so that you can also do the same. You can also follow the same step as I'm doing, and then we will go to this go to docs, and now you can see we have all the documentation related to the Soroban platform. Now in order to install it, I will simply go to this setup part, okay, and here you will find all the installation step that we will be doing in order to install the Soroban platform. And trust me, the documentation are pretty good. I will say after so much long time I'm seeing this kind of documentation where you can simply follow the documentation and everything will be set. Okay, so let's start. So in order to use the Soroban platform, we need Rust, because at the end of the day we are going to write Rust programming language, right? We are going to use Rust programming language in order to write our smart contract. So for that, I will be using the Linux environment. Okay, in your case you can also go for Mac OS, you can go for Windows, whatever suits you. And for Linux, I will be using Windows subsystem for Linux. Means I will be using my Windows operating system, and on top of which I will be running the Linux environment so that I can write the Linux environment. So you can either go for Windows subsystem for Linux, or you can also install Linux environment in the VirtualBox and then you can use it. And if you have a Linux environment already, like Ubuntu operating system already installed, then you can directly use that. So let me open terminal. Okay, so terminal, I will simply do run as administrator so that we do not have any administrator issues. Okay, and let me do this. Okay, so this will be much now nicer. So first of all, I will be installing Rust, okay, and I will be simply following the documentation, and I will be sharing the link in the description so that you can also follow that. And then I will simply copy this command and I will paste it. Okay, before that, because I'm using Windows subsystem for Linux, I need to write this WSL command. Okay, so that I have this bash. Okay, great. Now I can use this command. Okay, let me zoom in a little bit and let me copy this, paste it. Okay, so now you can see the Rust installation process has begun, and now it is saying that current installation options. Okay, these are some things, and then proceed with standard installation, customize installation, or cancel installation. So I will be simply doing the first part. Okay, so now the installation has started. Okay, so in my case, Rust is already installed, so that's why you are seeing this particular thing, that Rust is already installed. In your case, you will be installing Rust from scratch when you'll be writing this command. And simple process, nothing fancy, just write this command and everything will be set. Okay, and let me show you that I have Rust. So I will simply do, let me just clear the terminal. So here we will do Rust C -- version, and you can see that I do have Rust. Okay, now I will go to the next step, that is install the target. So let me just copy this. Okay, and I do have Rust up. So when you will be installing Rust, everything will be installed. Let me show you that as well. So version, yes. Okay, so now I can use this Rust up. So I can simply copy this, paste it, and it is saying that info component is up to date. Okay, because I already have the system configuration according to the documentation, so that's why it is saying that. In your case, it will be doing each and everything from scratch, as I said. Then we can go, okay, and there is certain steps that we need to see, that many editors have support for Rust. Okay, and yeah, so you can use whatever editor you want to use. I will be using Visual Studio Code, and that is, I think, something which we all use mostly. So yeah, I will be using that. Now I will go to the next step, that is installing the Stellar CLI. So I will simply copy this command, and since we have Rust, we do have Cargo as well, and let's do this so that I can install this particular Stellar CLI as well. So okay, we will be using it, so that's why. Okay, so this is done. Then we will simply copy this, paste it. Again, we need to wait for some time. And if you have a Mac OS, okay, then you can also use Brew in your case, but I'm using Cargo. So yeah, everything is working fine by my end. Okay, so this is done. Now we will go for this particular section. If you want auto completion, then you need to install this. So basically not install, you have to use this command. And to enable autocomplete permanently in future bash shell, then just run this command. Okay, so these are some steps that you need to follow. And now for configuring the CLI for testnet, since you will be using testnet, right, in order to deploy our smart contract, in order to test our smart contract, so I will be using this as well. Let me clear this, let me paste it here. Okay, so this is done. Now we are going to configure our identity. So let's copy this, paste it, Taylor keys, generate global ALS network testnet. Okay, let's do this. So here you can see that let's configure an identity called Alice. You can use any name you want. So if in your case you want some other name, then definitely you can use that. But it might be nice to have some name identities that you can use for testing. So they are saying that you can definitely have any other name, but it will be nice if you're using these names, okay, for the testing purposes. So now we can run this particular command. Okay, great. And now we can see the public address of Alice, because we have the Alice as our identity, right? So simply run this command and you can see this is the public address of Alice. So this is good, and we are good to go now because we have done all the steps that are necessary in order to use the Soroban platform. Okay, and now we will be starting with the smart contract development. So I have created a folder by the name of Hello Soroban in the Visual Studio Code, and now I will be writing simply this particular command in order to create a folder. Okay, so this command is given in the Stellar documentation, and I can show you that as well. So this is the documentation, and you can see this command is already given here. And again, I will share the documentation in the description. I'm saying this again and again so that you do not forget that everything is given in the description of this video. Let me press enter. Okay, it is saying that the reason is very simple, because I'm using WSL, right? So I should be doing WSL, then only I can write the commands. So now if I will do this, so yeah, now you can see that I have a folder by the name of Soroban Hello World. Okay, and here you can find that we have various folders such as contracts folder, then we have this cargo.toml, then readme.md and gitignore. Now this will be the main folder there where we will be working, that is inside this contracts folder, where you can find a source folder, and inside this source folder you will find a file by the name of lib.rs. Now this is the entry point of your program, means whenever you will run your program, this will be your entry point. Okay, and there is this code that is written, and we will be discussing about this code, so don't worry. And apart from that, you can see that we have this test.rs, which is actually testing this lib.rs file. Okay, so this file is being tested using this particular script. Again, we will be talking about this as well. Now, if you are familiar with Rust programming language, you must have seen this cargo.toml, and if you are not, then don't worry. It's simply, you can think of it as a package.json, where you are actually mentioning all the dependencies that you are using about your package. Like you can see that package is hello world, version, edition, publish, and the dependencies currently we have, that is Soroban SDK, and the dev dependency that we have is Soroban SDK, and all these things. Now let me open the lib.rs file where we are going to write our smart contract logic. And inside this file, you can see that we have this function by the name of hello. Okay. So let us understand how this smart contract is working so that when we will be writing our smart contract, we are familiar with the things that we need to do in order to write our own smart contract. So let us understand this file first of all. So this file contains this function by the name of hello where we are passing this to, right, this 2 as well as this env which is of env type and this 2 which is of string type, and we will talk about this env later on, but let's talk about the string which is a string, right, which is a string data type that we are passing to this function. And then what we are returning from this function is a vector which is having this hello as well as the string that we are passing to it. So what we are doing is we are simply passing a string to this function, and this function is then returning us with a vector having hello as well as the string that we have passed. So let's say if we are passing let's say we have passed world, so it will return us with hello world. And if we have passed, let's say ls, so it will return us with hello and ls. So this is simply what this particular smart contract is trying to do, is simply returning us with hello and whatever string we are passing to it. Okay. Now talking about the starting lines that we have in the smart contract. Now the first line that you're seeing is this no std, which is making sure that the Rust standard library is not included in the build. And the reason for this is very simple, because the Rust standard library is a large library, right? And which is not suited that, which should not be included during the build process, since we are going to deploy this smart contract on the blockchain. Okay, so that's why we have this particular line. And then we have this line, which is actually making sure, which is actually importing all the important components that we are going to use in our smart contract. So first thing that you are seeing is this contract. This contract that you're seeing is a procedure macro from the Soroban SDK, as you can see. Okay. Now this is to mark this Rust struct that we are using, this pub struct hello world, as a contract, so that the Soroban platform can recognize this as a valid smart contract. Okay. And then you are seeing this contract implementation, this contract MPL, that is the implementation of our hello contract. So this is our hello contract, and we are implementing the logic of our hello contract inside this particular block, this implementation block. And as we have discussed, that we have inside this implementation block, we have this function which is simply returning us with a vector, whatever thing we are passing to the function, and appending that thing with this hello, right? So we have hello ls, hello world, right, like all these things. And I will be running this program so that you can see that as well. And this env, right, this env is basically environment which is actually helping us to interact with the Soroban environment. So in order to access the storage of Soroban, in order to work with the blockchain, we require this environment, in which we will be using throughout all the function that we will be writing, and I will show you that as well when we will be writing our smart contract. And let's see what we have in the last. We have this mod test, so that we can use this test.rs, which is actually testing our smart contract. So you can see that we are simply calling the hello world. Basically, we are calling this hello function from our smart contract, and we are passing this dev, right? So we are passing this dev in this 2, okay? And what we are expecting is, as you can see, we have this assert statement, which is expecting that we will have hello dev returned from our smart contract, okay? Because we are passing there, right? And as we have understood the logic of this function, that whenever we are passing something to it, it is returning us with a vector, appending it with hello. So yes, at the end of the day, if we are passing dev to it, so we should have hello dev, right? And how we can test this? We have to simply go to the terminal, and let me open this particular folder right in the terminal. So I will simply do this, and let me do WSL here as well, so that I'm in the WSL environment, means the Linux environment. And now what I will do is I will simply write cargo test. Now this will actually test our smart contract, and before testing, you can see the compilation is taking place. We need to wait for a while. Okay, it will take some time. So you can see that 96 by 170, so it will go up to 170, and then we will have a test of our smart contract. And you can see that once we are doing that, since it is compiling also, we have this target folder. Inside this, we have this debug folder in order to debug, in order to test our smart contract. So we can also have a optimized version of our smart contract, but since we are simply trying to test our smart contract, we do not require an optimized kind of environment right now. We just want to test our smart contract, so we have this debug folder. So now you can see 160 by 169 by 170, and now the testing will be done in just few seconds. And this is done, and you can see that after, like, once the test is run, we have this test snapshot, this test1.json. Now inside this, you can see that in the terminal, you can see that running one test, and all the test cases have passed. So that's why it is saying that test result okay, one passed. Okay, this is nice, this is good. And if by any chance, let's say we have something, let's say Alice here, and if we will try to run this test case once more, you will see that the test case will fail. So again, the compilation is taking place. We need to wait for some time. So you can see the test case has failed. Reason is very simple, because when we are passing ls to our smart contract, what it is as what is actually what this particular function is returning us with is hello ls, but we are actually checking this hello ls against this hello dev, which is definitely wrong, because hello dev and hello ls are two different things, right? Two different vectors. So that's why it is failing. Okay, so this is how you can test your smart contract. Okay, and now what we will be seeing is how to build our smart contract and how to deploy our smart contract on a test network. Now, in order to build our smart contract, we will simply write a command stellar contract build, which will build our smart contract. So let's wait. So you can see that in the target folder, now we have this WSM32 unknown. Okay, and we need to wait for it to get built. So now the build is successful. In the WSM32 unknown folder, in the release, if you will see, we have this hello world.wasm, which is actually your build contract. Okay, and now what we can do is we can deploy our smart contract. So in order to deploy our smart contract, I will be simply using this particular command, okay, for the Mac OS and Linux user. So stellar contract deploy, and you can see that in the we have this WSM32 unknown, right? Inside this we have this hello world .WSM, which is actually our build of our smart contract, and then we have this ls. Since if you remember in the starting, we have while we were setting up, we have the ls, right, as the name, while as the while we were configuring the identity, we have this ls, right? So that's why during the deployment part, I will be using ls. If you have any other name, then please use that. And then we have the testnet, right, in order to deploy the smart contract on the testnet. So let's go back and simply run this command. Now you can see it will be deployed on the testnet, and you can see it has been deployed on the testnet. So hooray, this is a good step, congratulations. And here you can see that you can see the contract on this particular URL. Let me do control plus click, and let me click just to open. So now you can see our smart contract is deployed, right? And here you can see this is successful. This is the ledger, this is the process fees, and everything is mentioned here, right? And so this is good, this is nice, this is nice. And apart from that, you can see that we have basically this was the transaction, right? Since it was Explorer testnet transaction, and this was the transaction ID, and this is your contract, right? This is your contract address, as you can see, contract, and then we have this long hexadecimal string, and you can see the same string here as well, and we will be using this string so that we can interact with our smart contract. So make sure to copy this string and paste it somewhere so that we can use it. Okay, and let me show you this as well. Let me open this, doing control plus click, and now you can see this is your smart contract, this CAC6 something, which is hexadecimal number, a long hexadecimal number. So this was the time at which it was deployed, and everything is good, right? This is good, this is nice. So now what we will be doing is we will interact with the smart contract that is deployed on the testnet. Now, in order to interact with the smart contract, I'm going to use this particular command, which is again given in the documentation, that is still a contract invoke, and this is the contract ID. So in our case, the contract ID is different, so we will be using that. Then the source is alice, then testnet, and we are calling the hello function, right? So that's why we have this hello here. So let's copy this command. We will make certain changes, definitely. Okay, so the changes that we need to make, let me just paste it here so that I can simply change the contract ID here, and I will simply have the ID this, right? Let's copy this again, and now let me paste it. Let's see what is the result when we are interacting with our smart contract that is deployed on the testnet. And you can see that we have RPC. Why we have RPC? Because in the 2 we are passing RPC, right? In the lib.rs, if I will go back again, you can see that in the 2, whatever we are going to pass in the 2, we will have hello plus that particular string. So you can see hello and RPC. And if we will change it to something else, let's say if I will again paste the command, but this time with something else, that is Soroban. Okay, and I will simply copy this and I will paste it. Let's enter. Let's wait for it. And now you can see we have hello Soroban. So this is nice, guys. This is nice. What we have seen is from compilation to testing to deployment of our smart contract on the testnet and how to interact with our smart contract on the testnet. So now it's time to write some real smart contract on the Soroban platform. So let's start with that. Okay, so now it's time to create our own atomic swap smart contract. And for that, I will be doing Soroban contract init, and this time let the name be token atomic swap. And now you can see that we have token atomic swap. Let me open this in the dedicated terminal doing WSL so that I can write the Linux commands. Let me clear this. Okay, so now let me go to the contract. So we have the hello world contract, but now we do not require this. We will simply remove basically the entire code. Let us remove the entire code so that we can create the smart contract from scratch. So first of all, we will have our no std, right? We have discussed about this, that we do not want the Rust library to be included in the build. So that's why now we will have some packages that we will import from Soroban SDK. So SDK, then contract. Okay, in order to create the contract implementation, we will require address because we are going to deal with the account address as well as the token address, and then we will require the env. Okay, now let's create contract macro, and inside this we will have pub struct, and this time the contract name will be atomic swap contract, right? And here we will have contract impl, that is the contract implementation. Okay, so we have discussed about all these steps, so I'm not going in depth of all these things. Now I will simply implement the atomic swap smart contract, and inside this I will create a function by the name of swap. Now this swap function will be responsible for swapping the different tokens. So inside this we will have the env, right? This is important. We will have the account address. Let's say the account address is A, and another account address, okay, my mistake, and another account address is B. Then we will have the token smart contract, token A, okay, and again it will be of address type. We will have token B, again of address type. Then we will have the amount A, that will be of I-128 type. Okay, now this is the data type that is provided by Soroban only, so we are using that. Then we will have min b for A. Now this is the minimum amount of minimum amount of B that we require in order to swap it with A, and you will understand it once we will start coding this. So I-128, then we will have amount B, and inside this again basically this is also of type I-28, and again we will have minimum amount of A for B. Okay, so for B, which is the minimum amount so that the swap can take place, and this is it. Now first thing that we are going to do is we are going to check. Now what we are going to check is if amount of B is less than minimum amount of B for A, then we are going to simply do a panic. Okay, a panic, sorry for that, and we will simply have not enough tokens B for token A. Now once we will do that, what we will do is we will simply do a.require auth, then for arguments, that is args, and inside this we will have token dot a. We are simply going to clone it. We are not going to transfer the ownership, so we will simply clone it. Okay, and we will simply have token B and again clone it. Then we will have the amount of A, then we will have the amount of B, the minimum amount of B for it basically. Okay, and then we will do into val and E and V, and I'm going to explain you with this line, don't worry. Before that, just let me have this semicolon here and comma if you want to add some more things. Now what we are trying to do here is, now what this particular line is doing is, this line is checking for authorization. So whenever we are dealing with some token, we require a certain amount of authorization. Why we require this? Because when we are dealing with tokens, there are a lot of things that we can do with tokens, right? We can either transfer them, we can either swap them. So it is necessary to check for the permission that can we do this kind of stuff or not with the token, right? So this require auth for args is actually making sure that this entity, this particular A address, authorizes the transaction or operation that involves the following parameter. So the parameter that are involved here, this is for the authorization purpose, so that the transaction does not fail when we will deal with this particular token with this amount of A and this minimum amount of B for it. And in the same way, we will check for B as well. So we will have again this line, but instead of A, we will have B. And here we will have token B, right? So token B, this will be token A. And here we will have token P, and this will be A and this will be B. Okay. Now once this is done, we will create a new function by the name of move token. Okay. And inside this, we will pass the environment. We will pass token A. So token A, then we will pass A, we will pass P, and then we will pass the amount of A and the minimum amount of A for B. And in the same way, we will have for token B, then we will have B, we have A, then we will have B, and we will have B here and A here. Okay. Now let's create this move function. So we will have fun move token and env, that is env. We will have the token, and this will be of address type. From this will be again of address type because we are passing address type, right? And then to again of address type, and then we will have the max spend amount. So max spend amount that will be of I-128 type, and then we will have the transfer amount. Transfer amount again this will be of I-28. So what we are saying is that this is the environment, this is token A, right? This is the token A, and then we have the from address. This is and A and and B is the from address, or sorry, this and A is your from, and then we have this 2 as P, and then we have this maximum spend, though this is the maximum amount that we can spend, that is amount of A, and this is the transfer amount because we are saying that minimum amount of A for B. So this is the transfer amount that we require. Now once we will do that, we can simply create our function. And in order to do that, we will simply have let token. Now this will be helpful in order to interact with the token. So we will do client new, and inside this we will have the environment and the token. So this will be helpful. This token variable will be helpful in order to interact, in order to perform various operations related to the token, and you will see that. Now we will have the contract address, and which we can fetch from environment current contract address. Okay, so this will provide us with the contract address, and we will make one more change here. We will have the token because we are requiring that, and then we are using into val, right? So we will have this into val. Okay, so now we will be doing a token transfer. So okay, sorry for the mistake. Okay, now we will do token dot transfer. So you can see that this token variable is useful in order to call this transfer method associated with the token. So we will have token, we will have the from address, we will have the contract address, then we will have the maximum amount of spend that we have, max spend amount, And then we will again have a token dot transfer. Now this will be from and contract address to address, then the transfer amount. So transfer amount. And at the end, we will have, and I will be explaining you all these things, just don't worry. So at the end, we will have and contract address, then we will have the from, and then we will have and max spend amount minus the transfer amount. I know it is a little bit confusing, but don't worry, you will understand what I'm trying to do here in just a second. Okay, so this is good. So this is our complete smart contract, and I will be explaining you this line, just don't worry. But let me show you this complete contract. This is your complete contract, which will be responsible for the atomic swap. Now let us understand this particular thing that we are trying to do here. Now, in order to understand this, first of all, we need to understand the whole smart contract, what this smart contract is trying to do. As we know that this is an atomic swap contract, and here you can see that we have this move function also. So let us first understand what this move function is trying to do. So this move function, this move token function is trying to pass these arguments, right? So the first argument is this token, as you can see, this token. Then we have this address A, that is from address. This is address B. This is this to address, and then we have the amount of A in this maximum amount spent, and then we have minimum amount of A for B for transfer amount. So what this move token is trying to do is in the first call, like since we are calling it for the first time, in this first call it is trying to send token from A to B, where the maximum limit, where the maximum spend amount is this amount A, and the minimum amount of A that needed to be sent from A to B is minimum A for B, right? Because as I said in the starting only, that when A will be sending some token to B, there will be a minimum requirement set by B that, hey, you need to send me at least this amount of A so that I can transfer you this amount of B, right? So that's why we have this. And again, we are calling this move token. Now, why we are calling this move token again? So that we can transfer token B from B to A, where amount B will be the maximum spend amount and the minimum B for A will be transfer amount. So this will be the amount that will be transferred, but this is the maximum amount that we are setting, right? And since this is an atomic swap, if either any of these function call will fail, right, in order to execute, then the whole transaction will fail, right? Because we are calling this move function 2 times in the same function, right? So in like, we can say that this function is complete only when these 2 functions are complete, right? If any of these will fail, the transaction will fail. Now let us understand what this move function is trying to do. So we have seen that this move function is responsible for transferring token, right? Now in the first call, let's say if we are talking about this particular function call, the first time when we are calling this move token. So what we are doing is we are transferring token from, which is actually A, right? In this, but in the first scenario, A is the first person, right? The first person to transfer the tokens. So A is from, and then we are transferring some tokens to the contract address, as you can see, and this is the maximum spend amount. We are actually we are saying to the contract that this is the maximum spend amount you can utilize. Okay, so we are actually using contract as a, you can say, as a mediator, as an escrow, where we are first transferring the tokens to the contract address, and which is where maximum spend amount is the maximum limit. And then what we are doing is we are transferring token from contract address to the to address, that is the B address, right? Because B is 2, right? We have seen this. And then this is the transfer amount. Now why I'm having this transfer amount? Because as we have seen, this is the minimum requirement for this is the minimum A for B, right? So when A will be doing this transfer, A need to transfer the minimum amount of A so that A can get the B tokens, right? So this is the transfer amount. Okay, basically this is the amount that we are transferring, right, to the to address, that is the B address. And then what we are doing is we are transferring the remaining amount again back to the from address. So you can see we are transferring from the contract address to the from address, maximum spend amount minus transfer amount, because the transfer amount is the amount that we have already sent to the to address. So the remaining amount, right, the remaining amount will be sent back to the from address. Okay, so this is what we are trying to do with these 3 lines, and the same will be done for this second call of the move token, where the B token, where the B will be transferring some token to the contract address with the maximum spend amount, where maximum spend amount will be the amount of B, right? And then the contract will be transferring this amount to the to address with a transfer amount where this will be minimum B for A, and then again we are transferring back the remaining tokens back to B, since B has transferred the maximum amount, spend amount, right, to the contract address. So now we will again transfer the remaining tokens again back to B, so that B has the tokens, like the remaining amount of tokens after the transfer amount is sent to A address. Okay, so this is the whole idea of this atomic swap smart contract. Now let us try to compile this contract so that we can check we do not have any compilation issue. And first of all, I will go to this particular folder. I will simply do WSL so that I can write the Linux commands. Okay, and now I can simply do first of all clear Stellar contract build, right, so that I can check whether my contract is correct or not. Currently we have not provided the test file here because we are not testing it right now, but let's first check the compilation part. If there will be any issue, we will rectify it and then we can perform test on it. Okay, so there is this issue. We have this into val issue, right? Okay, it is saying that okay, we have some issues. Let me check these issues. So let's start from here. Expected, we have forgot a semicolon after this. So let me have a semicolon here. And then, okay, actually what we have forgot is this particular curly braces. That was the issue, I think. And then we have forgot one more curly braces, which will be here, I think. Yeah, so that's why it was saying that we are having the issues. Now let's check once more. Let's try to check this once more. Okay, now everything is good. Everything is good. So we have our complete smart contract ready. Now it's time to test this smart contract. So let me paste this test file here, with the help of which we are going to perform test on the on our atomic swap contract. Okay, let me explain you what we are trying to do in this test file. Now in the starting, in this part, what we are trying to do is we are trying to import all the components that are necessary in order to test this file. And in this function, we are trying to create a new token. As you can see, create token contract. So we are trying to create a new token. And what we are trying to return from here is, if you will see, we are trying to return the token client as well as the token admin client. Now, token admin client will be responsible for all the administrative tasks like minting the coin, and token client will be responsible for interacting with the client. Okay, not with the client but with the token. Okay, so this will be necessary if you want to interact with the token. If you want to do some administrative tasks, then we will be requiring this token admin client. And then what we have is we have this atomic swap contract. So now what we are trying to do here is we are trying to create our atomic swap contract. Okay, we are trying to create an atomic swap contract, and then we are returning this atomic swap contract client, with the help of which we can interact with it. Okay, with the atomic swap contract. Now this is our test cases. So you can see that this is our test case where we are trying to perform all the necessary tests that are required. So in the starting of this atomic swap function, you can see that we have these two lines. The first line is making sure that we have a default blockchain where we can test our smart contract. The second line is to mock the authorization, so that while we are running the test cases, we do not require any authorization during that, because we require authorization, right, in order to perform certain actions. But we are mocking that so that we do not have to do that authorization while we are testing our smart contract. Now these three lines that you are seeing right now, they are basically in order to generate some random addresses. So this is to generate a random address for A, this is to generate a random address for B, and this is to generate a random address for this token admin. Now you can see that we have these two lines in order to create a token contract with the respective token admin. And then what we are doing is we are trying to mint some tokens. So you can see that A is minting this 1000 tokens and B is minting this 5000 tokens. Now that's why we require this token admin, right? So that we can perform some minting of tokens, so that we can create some new tokens. Now you can see that we are creating the atomic swap contract. And then we are calling the atomic swap contract. So we are passing A and B address, then we are passing the address of token A and B, then we are passing the amount, right? If you will see in the starting, this is where it is. So this is your token A address, token B address, then this is amount of A, that is 1000. Now this is the amount of minimum amount of B for A, that is 4500. Then we have amount of B, which is 5000, and this is the minimum amount of A for B. So this is 950. Okay, so now what we are going to do is we are going to perform the test on these values, and then we are going to check the end result. And then you can see that what we are trying to do here is we are trying to do check on the authorization part. So you can find the same syntax, this syntax that we are using here, right? The same syntax you can see here also while we are performing the authorization in the contract. Okay, so this is the assert for the authorization part, and then you can see that we have an assert for the tokens. Now this is an interesting result, like this will show you the real part of the contract, the real crux of the contract, like what this contract is trying to do. So in the starting of the assert statement, what we are checking is whether the token balance of A is 50 or not. So after the swap has taken place, whether the token balance of A is 50 or not, this is what we are checking here. So if we will see the initial balance of A during the minting phase, so during the minting phase, A was holding around 1000 tokens, right? Now after A will transfer, or after A will swap some amount of tokens with B, how much token A will be left with? So if you will see, this 950 tokens is the minimum amount of A for B, right? If I will show you, this is the minimum amount of A for B. Means if A needs to swap some B tokens, A need to transfer at least 950 tokens to B address. So if A will transfer from this 1000 tokens, this 950 tokens, how much A will left with? A will be left with only 50 tokens, and that's what we are checking here. We are assuming that the swap has taken place, so now the balance of A will be 50 because 1000 minus 950 is 50, right? Now, since A has transferred A token to B address and A has transferred around 950 tokens to the B address, so we are checking in the second assert statement that the token A balance of B is 950 or not. So we are checking whether B is holding around 950 tokens of A or not. And this is true as well. Why? Because A actually has transferred 950 tokens to B. That's why A is left with 50. So this is absolutely correct. Now in the second assert statement, what we are checking is whether the token balance of B, right, is 500 or not. So after the swap function has taken place, after the swap function has been called, whether B is left with 500 tokens or not. Okay, so this is what we are checking. So this is the A balance, right? Remember, this was the A balance or A token balance. Now what we are talking about is B token balance. So token B dot balance. So let's again go back to the starting of the of the test file. So here you can see that initially B was holding around 5000 tokens, right? This was the initial balance of B. Now once B will transfer the minimum amount of B for A, and that is this minimum amount of B for A, that will be this 4500 tokens. So definitely after the transfer, B will be left with 500 tokens. Why? Because after the swap has taken place, from the 5000 tokens that B was holding, 4500 tokens has been transferred to the A balance, right, to the A address. So B will be left with how many tokens? B will be left with 500 B tokens, right? B will be left with 500 B tokens. You can also make sure that, okay, 50 A token balance. This was a 950 A token balance, right? And now what we are checking for the B tokens. So now B will be left with 500 tokens. So this is what we are checking in this particular assert statement. And there should be one more assert statement. So sorry, I actually erased it by mistake. So this was the another assert statement, and this also holds true, right? Because this is the amount that B has transferred to A, right? This 4500 that has been deducted from B balance is because 4500 has been transferred to the A address, right? So this is the 4500 is B token balance. So B token, when I'm saying B token, do not get confused with the B address. I'm saying that B token. Okay, so B token, and here I should be having A token so that you are not confused what I'm trying to say. So A token, and this is the B token. Okay, so if we will check this, it should hold true. Let's see. Okay, it should not be tokens, it should be B token. Okay, now let's try to test this particular smart contract with these values. If everything will be correct, if our swap function is working properly, we will see all the test cases will be passed, otherwise it will fail. Let's see this. So now what we will do is we will simply do cargo test, and let's wait for it to get complete. Okay, so you can see that it has neither passed or failed. Reason being, we haven't included the mod test here, right? My mistake. I should have mentioned this mod test. So let me try to test it once more. That's why it was showing that 0 pass, 0 fail or anything, because the test has not started yet. Let's see now. So now you can see that all the test cases has passed and 0 failed, because our smart contract, our swaps, atomic swap smart contract is working properly. And with this, we have completed our tutorial. So I hope you enjoyed today's tutorial, and if you have, let me know in the comment section. In this video, we have seen a lot of different things, right? We have seen how to use the Soroban platform, how to use the Soroban Rust SDK, how to compile our smart contract, how to deploy our smart contract, how to test our smart contract. And if you have enjoyed today's tutorial too, let me know in the comment section. So with this, let's have a wrap up. I will meet you soon in the next video. Till then, take care. Bye-bye.